Okay, so the first one we're going to do here are just simply adding and subtracting fractions. And the thing we have to remember here is we clearly just need to get a common denominator. Denominator, okay. All right, so if you look at the first one, it's 2/3 plus 1/4. Our common denominator is 3 times 4, which is 12. So I got to get both denominators 12. Okay, so I got to multiply. If I multiply the bottom on this one by 3, I have to multiply the top by 3. Okay, my common denominator here is also again 12. So I multiply by 4 over 4, which the reason for that is that's just a unique form of 1. Okay, all right. So if I have my denominator of 12. My numerator here, if I look at this, is 8. Second one also has a denominator of 12. I really only need to write it once. Plus 3. And now if I combine them, I get 11 twelfths. So if I were able to add those two together, the sum of those two would be 11 twelfths. And I did it simply by getting a common denominator. Okay. All right, our second one here is it also just has x's in the top. It doesn't make any difference. But if you look, our denominators are different, okay? So I have to get them together. So if we would have had one that was like 2/3 plus 7/3, then my denominators are already the same, and I'd get 9/3, which reduces to 3, okay? So this one, again, does not have the same denominator. Our common denominator is, I can just multiply those two together, and I get 21. All right, so this needs, I'm going to need to multiply top and bottom by 3. Okay, here I need to multiply the top and bottom by 7. Okay, so knowing that, I know my denominator is going to be 21. Okay, so let's just multiply these now. 4 times 7 is 28x. And here I'm going to get 5 times 3 is 15, so I get 15x. So now I can combine those together because they are like terms, and I believe is 43x over 21. And nothing divides both of those. Yeah, 3 is not a multiple of either of those, just like this cannot be reduced either. Okay, so the next one, the last one here is I have 2k over, or minus k over 4, which is the same as 1/4 times k. All right, my common denominator here is also 20. So I'm going to multiply by 5 over 5. This one I'm going to multiply by 4 over 4. So we know our denominator is 20, and how I handle subtraction is identical. Okay. So what do I have? 4 times 2 is 8k. Bring the sign along. Minus 5k. Since those are like terms, I can combine them, and 8 minus 5 gives me 3k over 20. Okay, so your key on adding and subtracting is just finding the common denominator and multiplying top and bottom by it. Okay? All right, whoops. So the next one I'm going to do is multiplication. And with multiplying fractions, we can multiply anything together. So multiplying fractions is actually quite a bit easier. All right, so you just multiply right across the top, but then we have to check at the end to see if we can simplify. So if I multiply across the top, 3 times 2 is 6, and x times x is x squared. Then on the bottom, it's 5 times 9 is 45. But now I have to look at, does anything simplify? And if you look at this, 3 divides both of those. 3 goes into here twice. 3 goes into 45, I believe it's 15 times. So that really becomes 2x squared over 15. Okay, I do want to go back here and look when it is multiplication, since I'm really looking to see if anything cancels on the top and the bottom, is if you look, nothing would have canceled with the 2 and the 9 or the 2 and the 5, but nothing here but the 3 and the 9. 3 goes into 3 once, 3 goes into 9 3 times. So then if you multiply across the top, I get 2x squared, and I get 15 on the bottom. So you can do it before or you can do it after. Okay. So here, if you look at it, if I choose to do it afterwards, It is a negative times a positive will be a negative. And 3 times 8 is 24. Then at the bottom, I get 28. Okay? Now, that does reduce because 2 divides both of those. 2 goes in here 12 times. And then 2 goes in here 14 times. But if you look at that, that's still even. So 2 would have gone in twice, so both of those are really divisible by 4. But you could have done it as negative 6 over 7 as your reduced form. Okay? Now, if you would have looked at the very beginning, nothing simplifies here, nothing simplifies here, you know, nothing here. But if you look, there is something that simplifies here. I'm not cross-multiplying. I'm seeing something cancels on the top and the bottom. 4 goes in here once. 4 goes in here twice. So then you get negative 6 over 7. Okay, so I'm going to look at this one first. I'm going to look at canceling first. Okay, so if I look, nothing simplifies here or here, but if you look at these two, 3 goes in here once, 3 goes in there 9 times. Okay, 2 divides both of these, goes in here once, and it goes in there twice. So now I'm just going to multiply together what's left, and that's 2, and then on the bottom is 9. Okay, if I hadn't done that, I would have had 12 over 54. Is that right? Yeah, 2 times 7. 6 divides both of those. 6 goes in here twice. 6 goes in there 9 times. Okay? So that's multiplying. Multiplication is usually the easiest because of you just multiply across the top and bottom and then simplify, or you can simplify first. All right, the last one is division. And many sometimes do this with a calculator, but knowing both. So I'm going to set them up where there's a division sign or they're set up as something over a fraction. A lot of people hate these, but I'm going to show you a relatively simple way. Is we're going to change this to be a multiplication because we're very comfortable with doing multiplication. So I leave the first one the same, and I flip the second one because I'm really doing the reciprocal. I'm sorry, it was negative 2/3. So what is the reciprocal of 1/5? Is 5 over 1. So I just flip and multiply. So now what do I get? Negative 10 over 3. I don't believe, nothing divides that, so I just leave it as negative 10/3. Okay? All right, so my second one, I leave 4/3 the same. And I'm going to change it. I'm going to flip this and change it to multiplication. So it's 3/5. And if you look, well, let's check, can I cancel anything? You bet I can cancel a 3. So it goes in there once. So what do I get is just 4/5. Okay? All right, now when you get a fraction over a fraction, you're really doing the same thing because we change it to multiplying by the reciprocal. So I'm going to multiply by the reciprocal of the denominator, which is 3/4. But whatever I multiply the bottom by, I got to multiply the top by. And the reason I do that is now this is 1. Okay? So when I multiply across the top, like I'm very comfortable doing, that's 3 over 28. And the reason that works, that original problem of 1/7 divided by 4/3 is the same thing as doing 1/7 divided by 4/3. Well, if you flip it and multiply, it's 1/7 times 3/4, which is what we had here. Okay? All right, so this is 1 over 2/3. So how would I get rid of the 2/3? Is I'm going to multiply by the reciprocal, which is 3 over 2. Because that gives me a denominator of 1. And what am I left with? Well, 1 times 3/2 is just 3/2. Because that's really 1 over 1. There I'm done. Okay? All right, so this last one, I'm going to make this negative 1/5 because that always comes up. It's kind of sloppily written, so let me write it as negative 1/5. So we need to multiply by the reciprocal, and the reciprocal of a number has the same sign. So it's 5 over 1, but it's also negative. So it's 5 over 1, but it's negative. So if you look at it this now, a negative times a negative makes it a positive, so that's gone. And then the 1s and 5s cancel. So this whole denominator is now 1, and what am I left with? 1 times negative 5 is negative 5. Okay? All right, Charles, if you come up with any others that you're struggling with, you can take a picture of them, or so I can be really specific on it, feel free to email that to me or text me. I'll help you out any way I can. Good luck. Thanks.